students! Today we're going to learn about prime factors of the composite number. Again, prime factors of the composite number. Let's recall first the prime numbers and the composite numbers. Let's start with the prime numbers. The one in the yellow shaded part, these are the prime numbers. 2, 3, 5, 7, and so on. For the composite numbers, the one in the yellow shaded part as well, 4, 6, 8, 9, 10, and so on. These are the composite numbers. There are two ways in finding the prime factors of the composite number. Again, there are two ways in finding the prime factors of the composite number. First, using factor 3 to present in diagram form. Again, using factor 3 to present in diagram form. Second, using short division. Again, using short division. Let's take a look at the example using the factor 3 and the short division. Here is the example in finding the prime factors of each number using factor 3. We have here number 4. First, think of a smallest factor of 4 that is a prime number. What is that number? Yes, 2. So 2 times a number is equal to 4. What is that number? 2. 2 times 2 equals 4. We have 2 and 2. And we all know 2 is a prime number, right? So therefore, the prime factors of 4 is equal to 2 times 2. For number 6, again, think of a smallest factor of 6 that is a prime number. That number is 2, right? So 2 times a number is equal to 6. What is that number? 3. We have 2 and 3, and we all know 2 and 3 are prime numbers. Therefore, the prime factors of 6 is equal to 2 times 3. For number 8, think of a smallest factor of 8 that is a prime number. The same as with 4 and 6, the smallest factor of 8 that is a prime is 2. So 2 times a number is equal to 8. What is that number? 4. As we can observe, we only have one prime number, which is number 2, because 4 is a composite number. If that is the case, continue the process. So think of a factor of 4 that is a prime number. 2, right? So 2 times a number is equal to 4. So that number is 2 also. So from here, we have the prime numbers already. So let's stop. Therefore, the prime factors of 8 is equal to 2 times 2 times 2. Another example in finding the prime factors of each number using factor 3, we have here number 9. Now, let's think of a factor of 9 that is a prime number. What is that smallest factor of 9 that is a prime number? Yes, number 3. 3 times a number is equal to 9. What is that number? 3 also. So from here, we have already the prime numbers. So the factor of 9 is equal to 3 times 3. For number 21, think of the smallest prime factor of number 21. What is that number? Yes, 3. 3 times a number is equal to 21. What is that number? 7. So 3 times 7 equals 21. As we can see, 3 and 7 are prime numbers already. So let's stop. The prime factors of 21 is equal to 3 times 7. For the last one, we have 45. Let's think of the smallest factor of 45 that is a prime number. What is that prime number? Yes, 3. 3 times a number is equal to 45. What is that number? 15. As we can observe here, we only have one prime number because 15 is still a composite number. So let's continue the process. So let's think of a factor of 15, the smallest one, that is a prime number. 3 also. 3 times a number is equal to 15. What is that number? 5. So 3 times 5 equals 15. As we all know, 3 and 5, they are prime numbers. So let's stop in here. Therefore, the prime factors of 45 is equal to 3 times 3 times 5. Now, using the short division in finding the prime factors of each number. Again, using the short division in finding the prime factors of each number. We have here number 16. Now, let's think of the smallest factor of 16 that is a prime number, which when divided from 16 leaves no remainder. What is that number? 2. 16 divided by 2 is equal to 8. We all know 8 is a composite number. If that is the case, continue the process. So think of the smallest factor of 8, that is a prime number, which when divided from 8 leaves no remainder. What is that number? 2 also. So 8 divided by 2 is equal to 4. Again, 4, still a composite number. So let's continue the process. Think of the smallest factor of 4, that is a prime number, which when divided from 4 leaves no remainder. What is that number? 2. 4 divided by 2 equals 2. As we all know, 2 is a prime number. So let's stop in here. Therefore, the prime factors of 16 is equal to 2 times 2 times 2 times 2. For number 24, we have 24 divided by a number. Now let's think of the smallest factor of 24. That is a prime number, which when divided from 24 leaves no remainder. What is that number? 2. 24 divided by 2 is equal to 12. 12 is still a composite number. So let's continue the process. Think of the smallest factor of 12. That is a prime number, which when divided from 12 leaves no remainder. What is that number? 2. 12 divided by 2 is equal to 6. 6 is still a composite number. So let's continue the process. Think of the smallest factor of 6. That is a prime number, which when divided from 6 leaves no remainder. What is that number? 2 also. 6 divided by 2 is equal to 3. As we can observe, 3 is a prime number. So let's stop in here. Therefore, the prime factors of 24 is equal to 2 times 2 times 2 times 3. Another one for number 36. 36 divided by a number, and that number should be the smallest factor of 36. That is a prime number, which when divided from 36 leaves no remainder. What is that number? 2. 36 divided by 2 is equal to 18. And we all know 18 is a composite number. So let's continue the process. Think of a smallest factor of 18. That is a prime number, which when divided from 18 leaves no remainder. What is that number? 2 also. 18 divided by 2 equals 9. Now, think of the smallest factor of 9. That is a prime number, which when divided from 9 leaves no remainder. What is that number? 3, right? 9 divided by 3 equals 3. As we can observe, 3 is already a prime number. So let's stop. Therefore, the prime factors of 36 is equal to 2 times 2 times 3 times 3. Another example in finding the prime factors of each number using the short division. We have here number 20. 20 divided by a number, and that number should be the smallest factor of 20. That is a prime number, which when divided from 20 leaves no remainder. What is that number? 2. 20 divided by 2 equals 10. And we all know 10 is a composite number. So let's continue the process. Think of the smallest factor of 10, that is a prime number, which when divided from 10 leaves no remainder. What is that number? 2 also. 10 divided by 2 equals 5. So we can observe 5 is already a prime number. Let's stop in here. Thus, the prime factors of 20 is equal to 2 times 2 times 5. Next, number 30. 30 divided by a number, the smallest factor of 30, that is a prime number, which when divided from 30 leaves no remainder. What is that number? 2. 30 divided by 2 is equal to 15. 15 is a composite number, so let's continue the process. Think of the smallest factor of 15, that is a prime number, which when divided from 15 leaves no remainder. 3. 15 divided by 3 equals 5, and we all know 5 is a prime number, so let's stop in here. Therefore, the prime factors of 30 is equal to 2 times 3 times 5. Last one, we have 50. 50 divided by a number, and that number should be the smallest factor of 50, that is a prime number, which when divided from 50 leaves no remainder. What is that number? 2. 50 divided by 2 equals 25. 25 is a composite number, so let's continue the process. Think of the smallest factor of 25, that is a prime number, which when divided from 25 leaves no remainder. What is that number? 5. 25 divided by 5 equals 5, and we all know 5 is a prime number, so let's stop in here. Therefore, the prime factors of 50 is equal to 2 times 5 times 5. And that's all for today. I hope you've learned from our discussion. See you in my next video. Goodbye.